Hi, welcome to the session of error detection in ECU diagnostics. In this session, we are going to discuss method of error detection, common diagnostic trouble codes, which is called as DTCs, tool for error detection, response to detected error. Method for error detection. Error detection in ECU diagnostic involve several key methods. The first method will be onboard diagnostics. In any vehicle, there is a system called onboard diagnostic system, which is continuously monitor the performance of vehicle and its major component and subsystems. It detects the issue or error or fault by comparing each and every sensor data with respect to a preset threshold value. The sensor reading is suppose exceed the preset threshold value or going below to preset threshold value, it is considered as a fault of the component. Second method is diagnostic trouble code, which is used to indicate the error in the system, which is actually generated in the OBD system. The code helps to identify diagnose specific problem with the vehicle. And third method is self-diagnostic mechanism. In modern vehicles, nowadays ECUs are given the capability of self-diagnosis, which is mostly some AI based software system which is diagnosis or classify or predict the problem in the component from the analysis of sensor data. It may report the faulty sensor data or failing component with the help of inbuilt software of AI system. Common diagnostic trouble codes DTCs. The DTCs are standardized code that indicate specific problem with the vehicle. The common format of DTCs from OBD to diagnostic system is given on the right side. Any DTC code consists of 5 digits. The first digit indicates which of the part of the vehicle the fault is detected. The part of the vehicle or a subsystem of the vehicle where the fault is detected. For example, in the first digit, if the B alphabet is given in the error code, it indicate body code which include AC and airbag. So the B letter in the first digit indicate the repair is detected or fault is detected on body portion of the vehicle. And the C letter in the first digit specify it is the error code from chassis or chassis code. The chassis include ABS system also. So any error detector on chassis and ABS is generated with the first digit C alphabet. The P letter in the first digit indicate power drain code or engine and transmission system error code. So any error detected on engine and transmission system is indicated in the first digit of P. And U letter indicate network code, the wiring faults. So these four alphabet indicates four different subsystem faults in the first digit of the error code. The second digit in the error code indicate whether the error code is generic standard OBDC code or it is vehicle manufacturer special code. Sometimes the vehicle manufacturer will generate a special type of error code which is not governed by the standard OBD codes. So which is indicated by this flag bit in the second digit with the letter of 1, the numerical value of 1. So the 0 indicates in the second digit 0 indicates it's general standard OBD code. The 1 indicate the vehicle manufacturer specific code which is not governed or coming under standard OBD code. The third digit in the DTC code specify subsystem. The first digit is specify the subsystem and higher level abstracted subsystem. The third digit is further subsystem of subsystem where the error is detected is reported in the third digit. For example, in the third digit, suppose you have number 1 is there in the DTC code, then it indicates the fault is on the subsystem of fuel and air metering. If it is 2, it indicate fuel and air metering, but it is injector circuit in the injector circuit. The number 3 in this third digit indicate the error or fault detected is section is ignition system or misfire error. The 4 in the third digit indicate auxiliary emission control system faults. The digit 5 indicates vehicle speed control and ideal control system subsystem faults. And digit 6 is computer output circuit faults. Number 7 and 8 are on transmission subsystem faults. So these three digits indicate which subsystems the fault is detected, whether the code generated is generic or vehicle manufacturer specific code. And the last two digit actually giving what is the actual fault detected. So you can understand this fault description by taking few example DTC code which is given in the left side. For example, P0101 where the first digit P says that it is power drain error code and 0 indicate is generic OBD standard code and 1 indicate it is at the fuel air metering subsystem the fault is detected and 01 the last two digit says this is the fault of mass airflow sensor fault. Similarly, if you take second error code, P indicates power drain code, 0 is standard OBD code, and 1 says that it is at fuel and air metering section, and the number 20 says it is throttle pedal position sensor malfunctioning. Similarly, third code, the last two digit says that it is O2 sensor circuit malfunctioning. The next code P0215 says that it is the fault of power drain and it is standard OBD code and it is the fault at the fuel and air metering of injector circuit because the number 2 says that injector circuit and the number 15 indicate it is engine shut off solenoid malfunction. Similarly, you can understand other code for P0300, it is random multiple cylinder misfire detected, and P0442 is small system leak in evaporative emission control system. P0500 says that vehicle speed sensor malfunctioning, and P0650 says that malfunction indicator lamp control circuit malfunctioning. So these are the few example code like that. A lot of codes there. You can look into some other sources for exclusive list of the code and meaning. Right. Next, tools for error detection. So the OBD system or self-diagnosis system in the vehicle is diagnosing the fault and it is generating error code and stored in the ECU unit. Then how to get those data, what tool we can use? So we can use three type of tools to collect the DTC code and further proceed for the repair and replacement. The first tool is OBD2 scanner. So these devices are plugged into vehicle diagnostic port. There is a port called diagnostic port with the CAN bus support probably, and those ports are used to communicate with the ECU to the external entity like diagnostic tools like OBD2 scanner, etc. So we can plug the OBD scanner into the diagnostic port, and we can read the DTC code generated by the onboard diagnosis systems. The second tool is diagnostic software. Some automotive manufacturer or a repair provider, service provider, they can use their own sophisticated software specialized to diagnose exactly and accurately uh, for finding the faults in the vehicle system by interacting vehicle ECUs. So that is also possible. Specialized diagnostic software developed by the repair shop or some specific vendor or vehicle manufacturer. Right. Third tool is handheld diagnostic tool. There may be some portable devices like your mobile phone or tab, which can perform comprehensive diagnostic of entire vehicle, including live data monitoring and sensor testing. So these are the three type of tool. One is standard OBD scanner, and the second one is specialized diagnostic software, which is developed by a particular repair shop or service provider. And the third one will be a handheld diagnostic tool like a mobile phone and tab. Response to detected error. So once the errors are detected, what are the steps next to repair and replace the component? The step number one, code reading and analysis. So we use any one of the diagnostic tool, earlier we discussed it, and we can collect the DTC code. Then we can analyze the code to understand what is the underlying issue or fault. Once we identify the fault by reading out or interpreting the DTC code, we have to further confirm it by testing the particular component where the fault is indicated in the fault code. So we have to test the particular component to confirm the component is not functioning actually. So before to repair and replace, this is the step we have to carry out. And third step is repair and replacement. So once we confirmed by testing the component, the faulty component which is indicated by the ETC, we can repair those component if it is repairable, or we have to replace the component. Right, for example, faulty O2 sensor could be replaced if the DTC codes are generated. Some component you can repair, some of the component just you have to replace. And fourth step is, so once you rectified the problem, you have to clear the faulty code which is stored in the vehicle system. Otherwise, the faulty code will generate the fault indication to the user without non-stop. So we have to clear the code after repair and replacement task is over from the ECU. So for that, most probably we will resetting the ECU once all the repairs are done. And fifth step is, after resetting the ECU and removing the error code, we have to do post repair action of verification whether the replaced component or repaired components are functioning well or not. We have to test to ensure the issues are resolved in order to avoid further DTC codes. So these are the steps followed to repair and replacement with the help of DTC codes